welcome back. In this video, we're going to do 3 examples using logarithmic differentiation. The first example is the function f of x equals x to the square root of x. Notice that the base is a variable, but also the exponent is a variable. It's not x raised to a number, like x squared. So we can't use the power rule on this. We cannot bring down the exponent and reduce the exponent by 1. That doesn't work when we have a function in the exponent. Also notice our base is not a number. So we can't use the formula for the derivative of the general exponential function b to the u. The derivative of that is just b to the u times the natural log of b times the derivative of u using the chain rule. We don't have a number in the base, so we can't use that. Our only option is logarithmic differentiation. So to use logarithmic differentiation, we rewrite this equation as y is equal to x to the square root of x. So we can take the logarithm of both sides, where we know y is a function of x. Now, I could use any logarithm. I could use base 2 or base 5 or base 10 if I wanted to, because the reason we use logarithms is so we can use the properties of logs to rewrite the function. But the nice thing about the natural log function is the derivative formula is simpler. So that's why we use natural logarithms. So let's use it by taking the natural logarithm of both sides of this equation. So we get the natural log of y is equal to the natural log of x to the square root of x. Now, using a property of logarithms, we can rewrite the right-hand side as the square root of x times the natural log of x. All right, so now we're ready to differentiate. We're going to differentiate both sides of the equation with respect to the variable x. Notice on the left side, I have a function of y, but I have to remember y is an implicitly defined function of x, so we can use implicit differentiation on the left side. So on the left side, we differentiate the outside. The derivative of the natural log is 1 over the inside, times, we have to multiply times the derivative of the inside, so that's y prime. On the right side, we just have the product rule. So we're going to use the first times the derivative of the second, plus the second times the derivative of the first. All right, now we want to solve this equation for y prime, so multiplying both sides by y, I get y prime on the left. On the right, I get y times all this stuff, and I'm going to simplify it a little bit. So square root of x divided by x is 1 over the square root of x. And then I have plus natural log of x over 2 times the square root of x. And now I want to replace y with the function x to the square root of x, and also y prime with f prime of x, because that's what I was looking for. So I get f prime of x is equal to x to the square root of x times 1 over the square root of x plus natural log of x over 2 square root of x. All right, and that's it. We don't have to simplify any further. Let's do another one. So here we're going to differentiate the function y equals sine of x raised to the natural log of the cosine of x. Once again, we cannot use the power rule because our exponent is not a number, it's a function. And we can't use the general, the formula for the general exponential functions because the base is not a number. The only option we have is logarithmic differentiation. So it's already written as y equals a function of x, so let's just take the natural log of both sides. So natural log of y is equal to the natural log of sine of x raised to the natural log of cosine of x. Now, using properties of logs again, we can bring down that exponent, so it's the natural log of the cosine of x times the natural log of the sine of x. And just to make sure it's clear, this is a product. I'm just going to add parentheses just for clarification. So now we want to differentiate both sides of the equation. On the left side, we have a function of y, but remember, y is a function of x, so we're using implicit differentiation on the left side. On the right side, we do have the product rule, plus the chain rule and the derivatives of natural log, cosine, and sine. All right, so on the left side, we differentiate the outside with respect to the inside and multiply by the derivative of the inside. On the right side, we're going to use the first times the derivative of the second, so it's 1 over the inside times the derivative of the inside, plus the second times the derivative of the first. So it's going to be 1 over the inside times the derivative of the inside. All right. So now we can simplify that right side a little bit. And we're going to multiply by y on both sides. So multiplying the left side by y leaves us with y prime. And on the right side, we're going to have y times, and I'm going to rewrite the first term as the cotangent of x times the natural log of the cosine of x. The second term is going to be rewritten as negative tan x times the natural log of the sine of x. And now I just need to replace the y with sine x raised to the natural log of the cosine of x. And there's my answer. Sine of x raised to the natural log of cosine of x times cotan x times natural log of cosine x minus tan x times natural log of sine x. And that's the derivative. All right, let's do one last example. In this example, we're asked to find y prime if all we know is x to the y equals y to the x. And we have to treat y as a function of x. And obviously, it's an implicitly defined function of x. So let's start by taking the natural log of both sides of that equation. So the natural log of x to the y is equal to the natural log of y to the x. Now let's use a property of logarithms to bring down the exponent, so it's y times natural log of x equals x times natural log of y. Now we can start differentiating. We have the product rule on both sides. We also have to remember y is an implicitly defined function of x. So on the left side, we're going to have the first times the derivative of the second plus the second times the derivative of the first. And on the right, the same thing. The first times the derivative of the second plus the second times the derivative of the first. All right, so now we'd like to get all our y primes on one side and everything else on the other. So on the left side, I have natural log of x times y prime minus x over y times y prime. So I subtracted x over y times y prime from both sides. And I subtracted y over x from both sides. So on the right side, I'm left with natural log of y minus y over x. All right, so on the left side, let's just factor the y prime out. So we have y prime times natural log of x minus x over y. And now I can divide both sides by the natural log of x minus x over y. So I'm left with y prime equals the natural log of y minus y over x over the natural log of x minus x over y. And there's nothing else I can do because we don't know what y is explicitly as a function of x. So this is our derivative with respect to x. All right, so you'll have some logarithmic differentiation problems in your homework. There are some problems where you're told to use logarithmic differentiation, but there are also other methods that will work. Whenever you see a function which has a variable in the base as well as the exponent, there's no other method that will work. But with other problems, you might have an option, but logarithmic differentiation may make your life easier. All right, I will see you in some other videos.